Hello, this is Jung Jung. I'll explain the course entitled Introduction to Computer Networks. Today I will explain Chapter 7, Wireless and Mobile Networks, Part 2. This is Jung Jung. This is the outline for today. We'll study wireless networks, especially cellular networks, fourth generation and fifth generation, 4G and 5G. 4G and 5G cellular networks are the solution for wide area mobile internet. They are widely spread, deployed, and used nowadays. The number of mobile devices is much more than fixed devices. The ratio is 5:1 in 2019. 4G availability 97% over time in Korea compared with United States such as 90%. Transmission rate up to 100 megabps. The technical standards are generated by third generation partnership project entitled 3GPP. This is a website, www.3gpp.org, and the 4G, the official name is long-term evolution LT standard. 4G and 5G cellular networks, they are similar to a wired internet. The edge and core distinction, but both belong to the same carrier. And global cellular network is a network of networks. The widespread use of protocols, we already studied HTTP for World Wide Web, DNS, domain name service, TCP and UDP for transport layer protocol, IP network protocol, NAT, network address translation services for private IP addresses, separation of data and control planes like SDN, Ethernet, and tunneling, and interconnected to a wired internet. The differences from wired internet, they are using different wireless link layer. Mobility is the first class service. User identity is identified using SIM card. SIM, SIM stands for Subscriber Identification Module. Business model, the users subscribe to a cellular provider like in Korea, SK Telecom, SKT, KT, LG U+. Strong notion of home network versus roaming in or on visited networks. Global access with authentication, infrastructure, and inter-carrier settlement. This figure shows elements of 4G LTE architecture. So you can see user equipment, mobile devices, smartphone, vehicle, base station. Evolved base station node, it is called the node B. And this core laid access network LAN. Okay. So, on the right hand side, there is a core network. Okay, so core network, it is called the All IP Enhanced Packet Core (EPC). Consists of Mobility Management Entity (MME), Home Subscriber Service (HSS), and we have two gateways. The first one is solving gateway, called the SGW, S gateway, and the other gateway called PDN, Packet Data Network Gateway, PGW, P gateway. Okay, so all access network and core network, those network are IP. It is called all IP network. Okay. Mobile devices. Okay, we saw home, smartphone, tablet, laptop, IoT devices. 64-bit international mobile subscriber identity (IMSI) is used. It is stored in SIM card. Okay, and LTE jargon, user equipment (UE) is used. Base station is the edge devices located at edge of carrier's network, manages wireless radio resource allocation, mobile devices in its coverage, called the cell. Okay, this is called the cell. Coordinate device authentication with other elements. Okay, like MME for identify mobile device UE. Similar to Wi-Fi access point, but active role in user mobility, coordinate with nearly base stations to optimize radio use for resource management. Node B is base station for LTE. Home subscriber service HSS stores information about the mobile devices for which the network of home subscriber service HSS is the home network. It works with mobility management entity MME in device authentication. Solving gateway, S gateway, PDN gateway, P gateway. S gateway is a gateway to connect inode Bs, right? This inode Bs are connected to S gate. This is S gateway, and the forward UE package as a router. Okay, so package forwarded S gateway, and then eventually forwarded to P gateway. P gateway connected to the outside internet. P gateway is a gateway to mobile cellular network. Looks like other internet gateway router provides NAT services, network address isolation services for private IP addresses. Eventually, P gateway is connected to data network like internet. Other routers, expensive use of tunneling. Mobility management entity, MME, performance device authentication, device to network, network to device, coordinated with mobile home network HESS, home subscriber service, mobile device management, like device handover between cells, tracking, paging device location, and the path setup, like tunneling setup from mobile device to P gateway. Eventually, you can see UE here connected to base station. Base station set up the GPT tunnel, GPRS tunneling protocol. GPT tunnel here, GPT tunnel from S gateway to a P gateway. Two GPT tunnels are set up. Okay. So LTE data plane control plane separation. Okay. So control plane. So this is a control plane. So HSS home subscriber service identify the mobile user and the registration information registered here. MME in charge of mobility management like handover, identification of mobile device. Okay, so control plane means a new protocol for mobility management, security authentication, and the data plane means a new protocol at link and physical layers. So especially data porting paths from a base station by S gateway, P gateway. Okay. Expensive use of tunneling to facilitate mobility. Okay, so those the tunnel IP tunnels are GPT tunnel. Okay, so let's take a look data plane protocol stack first hop. So you can see this is UE, this is base station. So it has a physical layer and 3 sub layer construct one layer link layer protocol. Okay, and the upper layer is IP and the transporter layer application layer. Okay, so link layer LT link layer protocol consists of 3 sub layer protocols. The first one is packet data convergence protocol, PDCP. It plays a lot of header compression and decompression and encryption and decryption of packet data. And second sublayer is radio link control RSC protocol, RLCP. Performs fragmentation and disassembly of IP datagram, such as big IP datagram is fragmented into multiple layer 2 frames. Okay, and then those frames transmitted sender and the receiver assemble. Okay, reassemble, something like that. And reliable data transfer like automatic repeat request, it is called the ARP protocol. Some packet is lost, and then so acknowledge and negative acknowledge message used to handle those loss of packets. It is called the ARP protocol. And the third one is medium access control MAC protocol. Performs transmission scheduling, such as requesting and use of radio transmission slots for actual delivery of frames. Also performs error detection and correction. Okay. Okay. Here, LTE radio access network LAN. So downstream channel upstream. Okay, so downstream means from base station to UE. Okay, so UE receive data packet from base station. So in that case, the downstream channels used. Okay, so downstream channel case a combination of FDM, frequency division multiplexing, and TDM, time division multiplexing used. Okay, within a frequency channel. So this combination of FDM and TDM called OFDM, orthogonal frequency division multiplexing. Okay, so orthogonal means minimal interference between channels. Okay, so sub channels are simultaneously used to minimize interference. Also, the time slot also used for those channels. So that's why a combination of FDM and TDM is used. On the other hand, the upstream channel, so from UE to base station, so this is upstream. Also, the same way, a combination of FDM and TDM, OFDM is used. Okay, and each active mobile device is allocated 2 or more 0.5 millisecond time slots over 12 frequencies for LTE. Scheduling algorithm is not standardized up to operator, and 100 megabps over device is possible. So this figure shows a packet cover. Okay, so the UE transmit the packet, and then so the packet received by user base station. This is a base station in node B. Okay, and then using tunneling protocol, it is called GPRS tunneling protocol. It is called GPT. sent inside the UDP diagram to S gateway. So basically base station using GPT tunnel and then forward the data toward S gateway, and also forward to P gateway. Okay, so this GTP, GPRS tunneling protocol, GPT, and GPRS. Originally, this is general packet later service for 2.5. Okay, G 2.5 generation network. Okay. S gateway tunnels the diagram to P gateway like this. Okay, so the tunnel, okay, something like that. So and supporting mobility, only tunneling endpoint change when a mobile user moves. Okay, so we will see. So base station is changes. This tunneling is changed to another base station. Okay, so associating with a base station, once a mobile device, okay, comes the communication range of a base station. Okay, so base station broadcasts primarily synchronization signal every 5 milliseconds on full frequencies, and multiple base stations from multiple carriers may be broadcasting sync signals. A mobile device finds a primary sync signal, then locates a second sync signal on this frequency. A mobile device then finds information broadcasted by base station channel bandwidth configurations. Base station's cellular carrier information also retrieved. A mobile device may get information from multiple base stations from multiple cellular networks and then select one base station to associate with, like preference for home carriers. Lastly, the more steps still needed to authenticate is establish the state, set up data plane. As in the Wi-Fi, Bluetooth, LTE mobile device may put a radio to sleep to conserve, that is, save battery energy. Okay, and the light sleep and the deep sleep. Light sleep is after 100 millisecond of inactivity. Okay, wake up periodically every 100 millisecond to check for downstream transmissions. Deep sleep is after 5 up to 10 seconds of inactivity. So mobile device may change cells while deep sleeping. It needs to establish the association, okay, with the new base station. And this figure shows global cellular network, like a network of IP networks. Okay, so this is a home mobile carrier network. This is UE's visited mobile carrier network. So also in the middle, the data network is the internet. So all this is access network, radio access network, LAN, core network, and data network, internet, all IP. Carriers interconnect with each other, and public internet at exchange point, okay, is used. And legacy second generation and the third generation, those are not all IP, handle the other way, okay. And the SIM card in your smartphone, right? So this includes international subscriber. The ID is embedded, okay. So global identity information in home network, and then using this SIM card ID, and then we can identify mobile device user, okay. So it can connect to home network first, and then roaming in business network. Okay, so on to 5G. The goal is 10 times increase in peak bit rate, 10 times decrease in latency, 100 times increase in traffic capacity over 4G. Okay, so 5G NR, it is official name is new radio. Two frequency bands are used. The first frequency band called the FR1. The range is 450 megahertz up to 6 gigahertz. And second frequency band is called FR2. The bandwidth is from 24 gigahertz to 52 gigahertz. This FR2 called millimeter wave frequencies. Okay, and the not backwards compatible with 4G. That's why 5G case carrier invest more money for the physical layer. And MIMO, multiple input, multiple output, means multiple directional antennae or antennas are used for simultaneous transmissions and reception. Millimeter wave frequency is much higher data rate, but the limitation is over shorter distances. So cells diameters 10 to 100 meter. So massive dense deployment of a new base station are needed. That's why 5G deployment costly. So 5G, you can refer to this 5G system overview. The 5G is on top of software virtualization and virtualization. 5G networks are constructed by network functions virtualization, NFV. This is European standards body like ETSI, European Telecommunications Standards Institute. Okay, so release 15 from 30pp, the specification of 5G phase 1. This introduces a new radio NR transmission technique. Other key concepts are defined, such as on industry-grade reliability, on extended modularity, or a faster response time. 5G services. So overall, we have a 3 plus 1. The first one is enhanced mobile, the broadband EMBB for the wide up and the downstream transmission speed. And second one is critical communication, especially it is called the ultra reliable and low latency communication, URLLC. This is a 1 millisecond communication delay and reliable transmission delay services, okay, provided. So like virtual reality, augmented reality services are provided by 5G. And the third one is it is called a massive machine time communication, MMTC, for IoT devices. Low latency and low power communication is provided by 5G. This is called a massive Internet of Things, MIoT. So, and finally, along with the three of them, flexible network operations are provided by 5G. So the 5G architecture case, this is a user equipment. This is a radio access network. So base station is called G-Node B. G-Node B is a new radio evolved base station. Okay, so and then so you can see the F means function. So 5G case entities for network access network, radio access network, LAN, and core network, or elements are implemented by the virtual function or container like the Docker. So we have a function. This is user plane function. This is a session management function. This is a handover related access and mobility function. Okay. PCF is policy control function, something like that. Okay. Those functions are used, and this is data plane, data network. Okay. The upper one is a kind of control plane functions. Okay. This is open 5GS architecture. So this is open source to allow construction of 5G core network. Okay, so you can see this is GNodeB. Okay, so this is base station. Okay, so you can see the 5 meg. Okay, reliable link control. Packet data convergence protocol and RRC. Okay, so those are is base station, and then it is connected to upper one is control plane like access and management function, and right hand side user plane function like the packet gateway or S gateway. So the basic change from the LTE to a 5G case, all functions are softwareization, and the network functions virtualization using virtualized function is used for the network components. Okay. Okay, let's move on. Mobility management principles. So what is mobility? The spectrum of mobility from the network perspective: no mobility and high mobility. So no mobility means the device moves between networks but powers down while moving. And intermediate mobility, device moves within the same access point in one provider network. Okay, and the higher mobility means device moves among access points in one provider network. Okay, and the high mobility, device moves among multiple provider networks while maintaining ongoing connections. So we are interested in these both mobility scenario. So mobility approaches, let network or routers handle it. Routers advertise well-known name, address, permanent 32-bit IP version 4 address, or number cell ID of visiting mobile node via usual routing table exchange. So in that case, there is no change is needed. Routing table indicate where each mobile device is located via longest prefix match. So, but this approach is not scalable to billions of mobile devices. Let end systems handle it. Functionality at the edge. The first one is indirect routing. Communication from correspondent node to mobile node goes through home network, then forwarded to remote mobile device, mobile node. And direct routing is this is optimal routing compared with indirect routing. Correspondent nodes get the foreign address of a mobile node, and then it is able to send packet or datagram directly to mobile node. Okay, we have an analogy contacting a mobile friend. Okay, so I wonder where Alice moved to. Okay, so Bob wants to talk to Alice using mobile communications. So consider friend frequently changing locations. How do you find him or her? Search all phone books. Expect her to let you know where he or she is. call his or her parent, or you can looking at Facebook of your friend. Okay, the importance of having a home, a definitive source of information about you, a place where people can find out where you are. This is a home kind of a registry or registrar. So this figure shows the scenario, the moving from home network to visited network, 4G and 5G. So your smartphone identified by SIM card's ID, okay, global identify information including home network. Okay, so home network paid service plan with the cellular provider. Okay, in United States, Verizon. This is a cellular provider. In the France, Orange. Korea, SKT or KT LGU Plus. Home network, home HSS, home subscriber service, stores identity and services information. Okay, and then this connect to your smartphone connected to home network, and then registered here, and then moving to another network, like you going to foreign travel, like in the United States. It is requiring a roaming service, right? So moving to visited mobile carrier network. So visited network is any network other than your home network. Service agreement with the other network is required to provide access to visiting mobile node. Internet service provider, and the Wi-Fi network. There is no notion of global home. That is credentials from ISP like username, password, store on device or with the user. ISPs may have national, international presence. The difference, so they are different, using different credentials. Some exceptions, URAM, Euro, M, ROM, and the architectures like mobile IP for 4G like mobility service can be provided, but it is not used anymore. So let's take a look at generic mobility scenario, right? So this is your mobile device connected to your home network, and then so if you move to visitor network, you allocated a new IP address from the NAT, so your permanent IP address, this is international mobile subscriber identification, this is this bit number, so your device is connected to and registered with your home subscriber service, and the mobility manager handles handover, right? So correspondent node try to connect to you, okay. So the mobile device associated with the visited mobility manager first, like this is MMM, right, in the 4G LTE case, right? So, and the visited mobility managers registers mobile location with home HSS, home subscriber service, and the result, visited mobility manager knows about mobile device, and also this kind of contact from visited mobility manager. Home HSS knows the location of a mobile node, and the corresponding node, once this kind of setup, correspondent node uses the home address of your mobile device and datagram address, datagram IP destination IP address. Okay, and then this guy knows, right? And then using tunneling, home this gateway receive datagram forwards toward the bit network gateway using tunneling. Okay, and then this guy gateway visited gateway router forwards to mobile devices. Okay, like this. Okay, so the visited gateway router forward reply message to corresponding node via home network gateway and eventually reaches corresponding node, or directly forward here. So this POA1, okay, POA, this step is called indirect, okay, routing, and from here visited network gateway to correspondent node is called direct routing. Okay, so this is better in terms of delay optimization. Okay, so previous indirect case, you can see the reply message going to home network gateway and correspondent. This is a triangular problem. Okay, triangular routing. So request going here, respond is here. So in that case, a better way is this guy forward reply directly. Also, if correspondent knows the care of existing node address of this mobile devices, directly contact to this mobile device. Okay, so this triangulation routing is inefficient when a correspondent and the mobile nodes are in the same network. Okay, so mobile node moves among visited networks. Transparent to correspondent is important, but it is hard to handle this triangulation routing. The registered in new visited network is required, and new visited network registered with the home HSS, okay, of mobile node. Datagrams continue to be forwarded from home network to mobile node in new network. Okay, the good benefit is ongoing, like TCP connections between correspondent and the mobile nodes can be maintained using this kind of indirect routing. The mobility with the direct routing is better in terms of routing delay. So the first over correspondent nodes get the visited network address for the mobile device. Okay, so correspondent node contacts home HSS to get the mobile's visited network information, and the correspondent node addresses datagram to visited network address, and then directly forwarded, and then this guy is forward the packet. Okay, visitor gateway router forwards packet to mobile. Okay, so but the problem is this kind of case, the routing point of view not transparent. Okay, so we need to invent other some layer for this kind of handling direct routing. So mobility with direct routing overcome the triangle routing inefficiencies, but non-transparent to correspondent nodes means correspondent nodes must get care of address from home agent, which means the current allocated IP address of mobile devices from home agent. What if a mobile device changes between network? This is a kind of handover scenario. It should be handled, but with additional complexity. Okay, let's move on. Mobility management practice, 4G and 5G networks and the mobile IP. Okay. So from now on, mobility in 4G networks, major mobility task. Okay. The The base station association. So we covered earlier. So first of all, user equipment, smartphone, make association with the base station, identify this node, okay, and register each information and allocate IP address from base station. So mobile devices provides international mobile subscriber identification ID, okay, identifying itself for home network, okay, and the control plane compilation. So mobility management entity MME and the home HSS establish control plane state for mobile node. So mobile node is in the business network right now, okay, like business network. And the third one is data plane compilation. So MME configures forwarding tunnel for mobile devices. So mobile node and the UE and here direct communication, but base station S gateway make some tunnel, GTP tunnel, and this guy also home network case or GTP tunnel is required, okay. So MME configures tunnel forwarding tunnels for mobile device like smartphone. Visited and home networks establish tunnels from home P gateway to mobile. And the mobile handover, okay, this guy is moving to another, and then another base station is selected, and then S gateway also make a new GPT tunnel. Previous GPT tunnel is from this base station S gateway is terminated, okay. So mobile handover, mobile device changes its point of attachment to business network. It is called handover, okay. So comparing LTE 4G control plane elements, okay. So mobile device communicates with the local MME, mobility management entity, via base station control plane channel, okay. So MME uses mobile's IMSI, International Mobile Subscriber Identification information to contact mobile's home HSS, okay, home subscriber service. So to retrieve authentication, encryption, and the network service information. And home HSS, this is another S. HSS knows mobile now resident in the business network, okay. So base station mobile select parameters for mobile and base station mobile data plane radio channel, okay. So like this, okay. So make channel allocations, okay, done. And the configuring data plane tunnels for a mobile. So the first of all, base station and S gateway they make a GPT tunnel here, okay. And then also S gateway, P gateway also make a GPT tunnel. So business network, S gateway, and home network, P gateway, they make a GPT tunnel, okay. So S gateway to base station, S gateway, base station tunnel is established. When mobile changes base stations, simply change endpoint IP address of tunnel. Okay, so in the case endpoint, this base station IP address is changed. Okay, and as a gateway to home P gateway tunnel, implementation of indirect routing. Okay, so this is some streaming server. The corresponding node is going to this home network P gateway and the S gateway, right? This is implementation of indirect routing. And tunneling via GPT, GPRS tunneling protocol, GPRS is used, okay? Mobile's datagram to streaming server is encapsulated using GPT inside UDP, inside datagram. So IP datagram, there's a UDP, okay? So handover between base stations in the same cellular network. Okay, so data pass before handover here. Okay, and then after handover, data pass changed. Okay, so the firstly, so source base station S gateway make a GPT tunnel here, and okay, step 1, current source base station select the target base station, send the handover request message to target base station. Second step, target base station pre-allocates radio time slots for mobile device. Respond with HR handover request acknowledgement message with information for mobile node. And thirdly, source base station informs the mobile nodes of new base station. Okay, so mobile can now send via new base station. Okay, handover looks complete to mobile. And firstly, source base station stops sending datagram to mobile directly, just forward here, instead of forward to new base station. Okay, who forwards to mobile over radio channel. And the target base station here informs the MME management entity that it is a new base station for mobile load. MME instructs S gateway, okay, S gateway to change the tunnel endpoint from here to here, okay, and then like this, a new tunnel, GP tunnel, okay, established. Target base station acknowledges back to source base station. So handover is completed. You can release okay, resources for mobile node. And then seventhly, mobile node's datagram now flow through new tunnels from target base station to S gateway and P gateway. Okay. Okay. So we saw some handover in the 4G LTE. From now on, we will take a look at mobile IP. So mobile IP is for the wireless LAN solution. Okay. So mobile IP architecture standardized 20 years ago, RFC 5944. So long before ubiquitous smartphones, 4G support for internet protocols. Okay, it did not see wide deployment use of this mobile IP. Perhaps Wi-Fi for internet and 2G and 3G phones for voice were good enough at the time. So mobile IP architecture, it supports indirect routing to node via a home network using tunnels. And mobile IP home agent combine the roles of 4G home subscriber service, HSS, and home P gateway. And mobile IP port-in agent is a combined role of 4G mobility management entity MME and S gateway. And protocols for agent discovery in visitor network and restoration of visitor location in home network via ICMP, Internet Control Message Protocol, okay, extensions used. And mobile IP, originally the RPC is 3344 IP mobility support for IP version 4. So you can click this link, you can get RPC 3344. This one is revised to RPC 5944 with some updates, okay? And this mobile IP has many features we've seen. Home agent, foreign agent restoration, care of addresses, encapsulation, packet within a packet. This is encapsulation, right? IP packet contains inner IP packet. For tunneling, 3 components to standard: indirect routing of datagrams, agent discovery, and registration with the home agent. Okay, so this is indirect routing. Okay, so this correspondent node send packet destination is this is a mobile node. Okay, so permanent IP address of this node, it is moved to some business network, right? So it allocate the careable address, new address from this foreign agent. Okay, so this destination IP packet encapsulated with this careable IP address. Okay, encapsulate outer datagram, this inner datagram. Okay, so foreign agent receive this packet and then decapsulate and then forwards a packet to this. Okay, the second component is agent advertisement, like a home agent and foreign agent, right? Advertise service. Okay, by broadcasting ICMP messages. Okay, type field of this ICMP message is 9. Okay, so this ICMP usually for control, okay, protocol. So this is ICMP header for agent advertisement. Okay, so especially here router address, and this is the bit including home agent bit, foreign agent bit, right? And the R bit is registration required. Okay, and in that case, foreign agent case allocate the careable address, like some list address for mobile load. Okay, this is example for registration. So mobile load mobile agent here located some foreign network, okay, or business network, and then this foreign agent advertise advertisement message, right? ICMP agent advertisement including careable address. Okay, and this guy is send registration, okay, request message including each permanent IP address and its home agent IP address. Okay, and then this foreign agent forward registration request toward the home agent of a mobile node. Okay, and then these guys make registration reply, and then foreign agent forward. Okay, and then so after this step between home agent foreign agent, we establish the tunnel. Okay, for indirect routing. So wireless mobility impact on higher protocols, the logically impact should be minimal. The best effort service model in IP remains unchanged. TCP and UDP4 transport layer protocols can and do run over wireless and mobile networks, but performance-wise, packet loss, delay due to bit errors, discarded packets, delays for link layer retransmissions, and handover loss. Okay, more harsh environment. TCP interprets loss as a congestion. As a result, will decrease congestion window unnecessarily. Okay, and the delay impairment for real-time traffic, and the benefits scale resource for wireless links. Okay, in summary, for chapter 7, the wireless networks, wireless links and the network characteristics are learned. The Wi-Fi at 11 wireless LAN local area networks are learned, and on the other hand, the cellular networks 4G and 5G network we studied. The mobility networks, the mobility management principle and practice we studied, especially 4G and 5G networks, and also we studied the mobile IP. Finally, we discussed impact on higher layer protocols for mobility. Okay, so thank you for your attention. If you have question, please let me know. Thank you.